Hi, this lesson is all about an idea that we've already seen in Theme Zero in Year 9. It's an idea called the Volcanic Explosivity Index. And it's a way of measuring the, um, the magnitude of a volcanic eruption. We have, for earthquakes, the Richter scale. For volcanoes, it's the VEI. We've already looked at these different magnitude of eruptions in Theme Zero. What I want us to do today, though, is to see if we can apply that to the eruption we've been studying, Mount St Helens. Okay, so if we look at page 14, you'll see there I've given you a partially completed VEI table. What I'd like you to do, I'd like you to fill the rest of this table in. Now, we start with the volume of erupted material. Now, every step up the VEI scale, we see 10 times as much erupted material as the previous step. So, for example, for a severe eruption, a VEI of 3, we're going to have more than 10 to the minus 2 cubic kilometers. Okay, so we're just adding 1 to every to the power with every step. The frequency of eruption then, I'd like you to work it out over the last 10,000 years. And I've given you a list there, or a number of the eruptions that have happened in the last 10,000 years of each magnitude. So easy to work out what the average gap between eruptions of that size would be. Once you've done that, what I'd like you to do is look at Mount St Helens. You have a table there of the material that was erupted in the eruption of 18th of May 1980, both from the lateral blast, the eruption column, and also the pyroclastic flows that came. So to work this out, to work out the VEI for Mount St Helens, what we need to do is we need to add together each of those values and compare that then with the volume of erupted material. Two things to watch out for here. Firstly, the powers are different. If you're going to add them up, you need to have all of those quantities to the same power. Also, I've given you the data in cubic meters, not cubic kilometers. So you're going to have to do a conversion. Be very careful how you do that. There are not 1,000 cubic meters in 1 cubic kilometer. Okay. Okay, now's the time to press pause and have a go at those questions. See what you can come up with. Okay, let's see what answers you've managed to come up with. This is our table of VEI, and the first question was to calculate the volume of material of pyroclasts erupted out of the volcano. Remember, if we're multiplying by 10 using powers, what we do is we add 1 to the power with each step. So a 3 is more than 10 to the minus 2 cubic kilometers. A 4 is more than 10 to the minus 1. A 5 is more than 10 to the 0, which is 1 cubic kilometer. A 6 is more than 10 to the power of 1, which is 10 cubic kilometers. A 7 is 10 to the 2, so that's 100 cubic kilometers. And an 8 is more than 10 to the 3, which is 1,000 cubic kilometers. Just a vast amount of material. Okay, so that's question A. Question B then asks you to work out the frequency of these. So if we do these sums, by dividing the occurrence by 10 in 10,000, we see that we get a VEI2 roughly every 2.9 years, a VEI3 every 11.5 years, a VEI4 about every 36 years, a VEI 5 about every 119 years, a VEI 6 every 256.4 years, a VEI 7 every 2,500 years. A VEI 8 is more than 10,000 years. They're very, very infrequent. We're in super volcano territory there. Okay, I also asked you to work out the VEI for Mount St Helens. Now, to do that, we need to add together the material that was erupted in the from the three different sources. Now, what I've done here is I've taken the value that was 1.1 times 10 to the 9 and turned that into the same power as the others. So that becomes 11 times 10 to the 8. That means I can just add together all of the first numbers, which gives me that gives me 14.1 times 10 to the 8, or a better way to put that is 1.41 times 10 to the 9 cubic meters. Now, there are a billion cubic meters in 1 cubic kilometer. It's 1,000 times 1,000 times 1,000. So the total volume of material erupted in Mount St Helens was 1.41 cubic kilometers. Now, if we go back to our table and look at where that will fall, so that's more than 1 cubic kilometre, less than 10 cubic kilometres. So Mount St Helens was a VEI 5 eruption. Quite a big one of only a handful in the 20th century. Now, those of you that did the digging deeper, if we think about this idea of VEI, in some ways it's very useful. It does show us just the sheer quantity of material that's erupted. But what it doesn't do is tell us what type of erupted material is, whether it's fairly low hazard lava or whether it's very high hazard pyroclastic flows. And it certainly doesn't tell us the violence of the eruption, how quickly this is erupted. Now, some of these are similar issues to the Richter scale. The Richter scale does show us the magnitude of an earthquake, but it doesn't tell us, for example, where it happened, or the acceleration of the ground, or the duration of the shaking. VEI has some similar limitations, but it is the best way we have at the moment of measuring the magnitude of a volcanic eruption. There are some things in the extension for you to have a look at, to have a think about the significance of this VEI scale. Anyway, next time we need to start thinking about how we start assessing risks from these different volcanoes. I'll see you then.